Hello and welcome to the third lecture of Elasticity. Sorry for getting late because of some personal issues and actually as out of station. तो थोड़ा बहुत लेट हो गया लेकिन आई थिंक आपका मैकेनिक्स वाला वीडियो आ चुका है ऑलरेडी सो यू कैन लुक ऑन दैट वीडियो. ओके. और आज हम लोग ये चैप्टर खत्म करने वाले हैं. इस चैप्टर को खत्म करने के बाद वी विल मूव ऑन टू क्वेश्चंस. ओके, ऑन टू सॉल्विंग द क्वेश्चंस. लेकिन आज हम लोग सिर्फ चैप्टर को खत्म करेंगे और बढ़िया तरीके से. सो वी आर गोइंग ऑन विथ इलास्टिसिटी एंड लेट्स सी कितना तक हुआ था हमारा. ये सब हम लोग का हो चुका था. नॉर्मल स्ट्रेस, स्ट्रेन, शियर स्ट्रेस, इलास्टिक लिमिट, हुक्स लॉ, यंग्स मॉड्यूलस, बल्क मॉड्यूलस, शियर मॉड्यूलस, कर्व और कुछ इंपॉर्टेंट पॉइंट्स लास्ट क्लास में मैंने कराए थे. अब ये जो टॉपिक है, यहाँ से थोड़ा बहुत जो टॉपिक आपका है, दिस पार्ट्स आर रेलिवेंट फॉर योर बेसिकली जेई syllabus. You should know the concept well. Let me change the color of my pen. Wait a bit. Okay. So extension due to self weight. Okay. So we have got a, you can call it a rod or you can call it wear. Okay. Let its area of cross section, first let's say its length. Its length is L and area of cross section is A. Okay. So now the thing that happens, let's say, what will be its volume? Let's say its volume is A into L. Okay. So this is its volume, na? A into L. So for, let's say this point, there will be a downward force due to its weight. So that will be mg, right? So what will be the weight? Weight will be my mg. Again, I know what is my mass. My mass is volume into density. Volume into density into g. Okay. Let's say this rod's density is uniform and it's denoted by rho. I can also give it d. In some books it is I think given in d, but let's consider here it is as rho. So volume मैंने तो निकाला है यहाँ पे, which is nothing but area of cross section into the length of the rod into density into acceleration due to gravity. Okay, now let's do one thing. You can I think easily see that let's say for this point, at each and every point when you are going upwards, okay, this weight, the force due to this weight will be different. Why it will be different? Because its effective length is changing. Okay, its effective length is changing. So let's do it. We take a strip. हम लोग एक छोटा सा strip ले लेंगे जिसका width है dx, मतलब length है आपका dx. ओके, और एरिया ऑफ क्रॉस सेक्शन तो आपका a ही होगा. So for this very small part, and let's say let's do another thing. This length, let's consider this as x. Okay. So weight on this very small strip, let's consider it w dash or w prime, is equal to, what will happen? Area is same, length is what? This is x, right? This is my now effective length, x rho g. Okay, now you know the formula for Young's modulus, right? Let me write it here. In the previous class मैंने आपको कराया था Young's modulus वाला formula. So मैं डायरेक्ट लिखूंगा, which is f into L upon a del L, and you need to find this del L. Okay, this is the extension part. So let's write as del L is equal to, so what will happen, this F, let's replace it by W dash. W dash into, now what will be this length? You are finding the strain, this is the part of the strain, na? L upon del L or del L upon L, this part, okay? You are finding the strain for this very small part. So you know this L is nothing but this length dx, okay? So write it as dx. Now area will be as usual because there is no change in area. And what will be del L? So del L I have taken it this side, so this side it will be y. And now let's substitute the values for W dash, which is A rho G x dx, okay? A rho G x dx whole upon your A y. Now this A and A gets cancelled out. So what will happen? Let's now integrate, okay? Let's integrate this part. Now यहाँ पे ये जो आपको एक्सटेंशन मिला ना, छोटा वाला डेल एल, एक्चुअली इसको छोटा वाला डेल एल ना लिख के इट विल बी फार बेटर कि आपने छोटे वाले स्ट्रिप के लिए डेल एल निकाला था. So to write it something like this del L, okay? Now when you integrate, now the extension will be del L for the whole rod, okay? Which will be is equal to, now you will do the integration from what? From 0 to L. You are considering this part to be 0, considering this part to be the reference point 0, और आपने इस point को L मान लिया है as your reference point, okay? So from 0 to L, let's do the integration of rho G upon y and x dx. So I think ये इंटीग्रेशन तो बहुत आसान है और आप कर सकते हैं इस इंटीग्रेशन को, which is rho G upon y is constant. So take it out of integration and x dot dx will be your x square upon 2, okay? So del L will be your rho G upon 2y, and now you have here x square, which is your limit from 0 to L. So you put on this limit, so you will get your del L is equal to rho G L square upon 2y. This is very important formula. This will be the total extension in the rod due to its own weight, okay? So rho G L square upon 2y. एंड आई थिंक फिर आप एक चीज देख पा रहे होंगे कि आई नो वेट विल बी इज इक्वल टू माई रो एल ए जी, दिस इक्वेशन, दिस वेरी इक्वेशन, ओके? W इज इक्वल टू रो एल ए जी. तो एक काम करिए, W अपॉन ए, okay, weight of the rod upon cross sectional area will be your rho lg. So आप इसको थोड़ा चेंज करेंगे तो rho lg into l, क्योंकि आपका l स्क्वायर है तो इसको आप w अपॉन a कर लीजिए और देखिए तो क्या आप इसको ऐसे लिख सकते हैं क्या, w into l upon 2a y. I think ये भी आप लिख सकते हैं and this is also a very important formula, okay? So these two are very relevant formula and questions can come from these parts. Okay, this is the extension due to self weight formula, क्योंकि rod अपने ही weight के कारण थोड़ा बहुत डिफॉर्म होता है, क्लियर? सो अगर आपको डेरिवेशंस में या फिर कैलकुलेशन में यहाँ पे कहीं प्रॉब्लम दिखाई दे रहा है, क्योंकि मुझसे भी गलती हो सकता है, तो प्लीज फील फ्री टू कमेंट। ओके, मैं नेक्स्ट पार्ट में फिर जा रहा हूँ, which is your another very interesting topic, thermal stress। अब इसको ना आप ध्यान से समझो क्या होता है आपका। This is now my thermal stress। So there is this rod which is constrained by these two boundaries। okay, क्योंकि rod मान लीजिए इस दोनों walls के बीच में, these are the walls। okay, sir, your walls, ताकि आपको समझ में आ जाए, these are your walls। तो this rod cannot break past these walls। okay, अब आपने क्या किया, मान लीजिए आपने यहाँ पे हीट सप्लाई किया। ओके, आपने हीट सप्लाई किया, तो हीट देने से इट इज एक्सपेरिमेंटली फाउंड दैट द लेंथ ऑफ द रॉड इंक्रीजेस। ये आप थर्मल प्रॉपर्टी में मैं आपको पढ़ाऊंगा, द एक्सपेंशन प्रॉपर्टीज। ओके, तो द रॉड्स लेंथ इंक्रीजेस, दिस इज कॉल्ड लीनियर एक्सपेंशन ऑफ रॉड, दिस फेनोमेना। ओके, बट आप यहाँ पे देख पा रहे हो कि there are some constraints that the rod cannot expand freely। So what will happen? There will be an internal stress generated। Okay, क्यों internal stress generate होगा? Because यहाँ पे आप देखो, rod will try to expand, so it will exert a force towards this side, but the, let me write it like there, it will try to exert a force from this side, but in case now this wall will generate an equal and opposite force towards this side। okay, so there will be a stress developed। so let's find first my strain। I will try to write it as E। okay, so thermal strain will be, I know, which is del L upon L, thermal strain, not longitudinal strain, del L upon L। okay, now what can we say about del L? Let me tell you a thing। यह फॉर्मूला थर्मल एक्सपेंशन में मैं आपको दिखाऊंगा कैसे आता है। इट इज आर एक्सपेरिमेंटली ऑब्जर्व्ड फॉर्मूला। okay, so del L will be actually, let me tell you, experimentally it is found that when you supply a heat to a rod or a solid body, it expands। now for a rod it is linear expansion, and this expansion is directly proportional to the original length of the rod, actually denoted by L0। so I'll write it here as L, no problem here। okay, and then it is also proportional to the temperature difference between the two ends of the rod। and I think you can relate, temperature difference आपका जितना ज्यादा होगा उतना ज्यादा आपका rod का length increase करेगा, because the more and more heat you are supplying there, right? so to remove these two constants of proportionality, I take another term here which is a constant, and I write this as L0 alpha del T, and this alpha is called the linear coefficient of expansion or coefficient of linear expansion। okay, similarly you will find for area you will write beta, wait, okay, we write beta, and for volume we will write gamma। okay, so now we will put these values in this equation। so del L, let's write it as L, not L0। okay, L alpha del T। so मैं आपको ये कराऊंगा, अगर आपको अभी यहाँ पे समझ में नहीं भी आया हो तो मैं आपको ये थर्मल प्रॉपर्टीज ऑफ मैटर में कराऊंगा। so whole upon L। okay, but this is very important, the questions are asked on this part, thermal stress। so L and L will get cancelled out। so what is your thermal strain? your thermal strain is alpha del T। okay, this is very important, thermal strain is your alpha del T। now from Hooke's law, you know stress, let me write it fully, okay, so that you can understand stress, let's say I'll call it as S upon my strain, which is I already have denoted by E, is equal to modulus of elasticity। now for a case of rod, what will be your modulus? I think it will be Young's modulus of elasticity, right? so I can give it Y। so stress, which I have denoted as S, will be is equal to your ई वाई, एंड ई हम लोग को पहले मिल चुका है यहाँ पे. लेट्स पुट इट हियर, अल्फा वाई del t, or you can better write it like that, y alpha del t. Okay, so this is your formula for thermal stress. This is very important part. Okay, this is the formula for thermal stress, y alpha del t, where s is your stress, y is your Young's modulus, alpha is coefficient of linear expansion, and del t is the temperature difference, okay, between the two ends of the rod. Clear? So this is the part of your thermal stress. Now we will move on to the next part. Let's move on to the next part actually. Wait a bit. Yeah. So we have got Poissons ratio. This is again a part which is very important from your JEE perspective. It is not in your NCRT syllabus. As far as I remember, it is not in NCRT syllabus, but it is very relevant for your JEE syllabus. Okay, both for JEE mains and advanced. So what is Poissons ratio? ये मैंने जो डायग्राम आपका ड्रॉ किया ना, इसको जरा समझ लो. अब इमेजिन कीजिए आपने आपके पास एक वायर है एंड यू आर स्ट्रेचिंग दैट वायर. ओके, सो पहले एकदम फर्स्ट में जब हम लोग यंग्स मॉड्यूलस वाला डेरिवेशन किए थे, तब से हम लोग एक चीज तब कंसीडर कर रहे थे तब से, क्या, वी आर इंक्रीजिंग द लेंथ, राइट. बट अगर आप इमेजिन कीजिए कि यू आर स्ट्रेचिंग द वायर सो दैट इट्स लेंथ इज इंक्रीजिंग, but there is a corresponding change in its area of cross section, right. इसका एरिया भी घट रहा है, घटना ही है, because I think you will observe, you can observe, आप कोई भी एक वायर ले लीजिए, आप उसको स्ट्रेच कीजिए, देखिएगा आपका लेंथ तो बढ़ रहा है, लेकिन एरिया ऑफ क्रॉस सेक्शन, इट्स द वायर इज गेटिंग मोर थिनर, right. So Poisson's ratio is nothing, I'll the ratio, it is the ratio of ls upon LOS. What is LS and LOS? LS is your, let me write it, okay, that you understand. It is your lateral strain. It is your lateral strain, and LOS is your longitudinal strain. Okay, I think now it is getting clear. What is lateral strain? Lateral strain is the change in the area, or you can say here radius. Okay, you can say radius. So Poisson's ratio, which will be PR. So PR will be your is equal to, let's wait. So your PR will be is equal to what? Lateral strain will be del R upon R, and longitudinal strain you know, which is del L upon L. But one thing you have to consider, as del L and L, let's say it is increasing, the length is increasing right here, okay, but this is decreasing, then the lateral part, the del R, this part is decreasing, and when you are applying del signs, you need to give a negative sign. This negative sign indicates that the lateral strain and the longitudinal strain are in the opposite senses. Okay, मतलब जब आपका lateral strain बढ़ेगा तब आपका longitudinal strain घटेगा, मतलब area of cross section आपका बढ़ा तो length आपका घटा. The more you stretch the wire, the more thinner it gets. Okay, so this is the part. Now the interesting thing what happens is that this note, okay, this is very important. The theoretical value of this Poisson's ratio, this is S, okay, this is nothing but your Poisson's ratio, lies between -1 to 0.5. But in practice, the value of sigma lies between 0.2 to 0.5. Okay. So यहाँ पे आपका sigma दिया, यहाँ पे S दे दिया, यहाँ पे गलत है, तो this will also be your sigma. Okay. So the theoretical value of sigma lies between -1 to 0.5. लेकिन प्रैक्टिस में क्या होता है, एक्चुअली आपका जो होता है इट वैल्यू लाइज बिटवीन 0.2 to 0.5. So this is the right value. Okay, the value of sigma for rubber is your 0.5. Clear? So this was your Poissons ratio. This is the ratio of lateral strain to longitudinal strain. And यहाँ पे आपने actual practical situation को consider किया है. Clear? So let's move on to the part where yes we have note and then strain energy, the last two parts. So यहाँ पे आपको बहुत ज्यादा कुछ बोलने का तो है नहीं, जस्ट मैं कहूंगा कि प्लीज डू ट्राई टू रिमेम्बर दिस formulas. These are absolutely essential. Okay, sometimes these formulas are actually very useful if you want to do a problem in a very small time. Okay, अब बहुत शॉर्ट पीरियड ऑफ टाइम में अगर प्रॉब्लम को करोगे और करना चाहते हो तो यू शुड रिमेम्बर दिस formulas, दिस इंटर कन्वर्जन formulas. This will prove to be useful. Okay, so it's up to you. Next I'll get into strain energy. Okay, so for strain energy, let's draw a wire. Okay, for example this is my wire whose length I know. Okay, whose length I know is L. So let's say I'm applying an area of cross section, I'm applying a force F here. Okay, so what will be my stress? I am writing as S. So S will be your my F upon A, and strain which I am denoting as E. Let me write it as X upon L. Okay, what is my X? Actually I am writing instead of del L X. Okay, for to avoid the confusion you'll see, because we will do integration later. Now you know the formula for Young's modulus again. Let's write it. Again, let's write the formula for Young's modulus. This part is very important. This Young's modulus. We'll need Young's modulus in each and every part. Okay. So I'm wrong. FL upon A, and instead of del L I have written X. So let's write X. So let's find this in terms of F. So F will be your is equal to YA X upon your length of the wire. Okay, so I think it's clear. Let's go down. Now for example, you are stretching this rod a little bit more, and the what your for that a little bit of stretching, let's say your dx elongation happened. Okay, there is a little elongation dx for your little bit force df. Okay, so there will be a very small work, right? Very small work will be done for this part, which you can definitely write it like I think f upon f dot dx. Sorry, f dot dx. So what is my f? I know that ya x dx, and this will be upon your L. Clear? So I want to find the total energy stored in the wire. So let's integrate for the total of its length, right? Let's take the integration limits from 0 to W, and for here your 0 to L. Clear? So this will be your W again. Simple integration. And again here integration is very simple, as YA upon L. This part is constant. Okay, I'm giving a bracket here for your understanding. YA upon L is a constant. I'll take it out of the integration. So YA upon L, and let's do it directly. Let's do it directly, as x dot dx will be your x square upon 2, which when I put with a limit will be L square upon 2. So 2 into L square. Okay, so this L and this L will get cancelled. So it will come y a l upon 2, right? So y a l upon 2. Okay, wait a bit, I think I made a mistake, right? Because the this integration, it is being done for the elongation part, right? So I should give it a del L here. Should have a del L here. Yes, I cannot cut this, huh? Because I am having this integration for the elongation part, this x and dx. Okay, so let's remove these parts. Okay, sorry, because I didn't take notice that time. Because I've been taking this integration for the elongation part, I should take the limit del L from 0 to del L elongation. So your W will be equals to YA, and this will be your 2L, it is right, but you cannot cut it because this will be your del L square. Del L square. Now let's do one thing. And again, I think for so that you don't have confusion, because del L square will have a different meaning. Let's put it like this actually, del L whole square. Now let's do one thing. Let's do a little bit of jugglery here. What we can do is that we can take half from here, then let's yeah, let's do this y into to my del L upon L. Yeah, we have got del L square, so let's write it like del L, and we can give another L here, and take another L, del L upon L into, we have got another del L, right? Let's write it like this. I think it will be similar. I think you will notice what is the trick here, del L upon L. But now you have to be careful, you have added one extra L. Del L is fine, it is squared, but here you have added extra L, so you'll have to write L here, another. And you have got an A which I have not used, let's write it here. So I think this very formula, each and every term you recognize, right? So let it take as half into, see, y is your Young's modulus and del L upon L is your strain, longitudinal strain. And we know what? Stress upon strain is your Young's modulus. So this part, this y into del L upon L part is nothing but your stress. So half into, I will be writing it fully, okay? Half into stress into, again del L upon L, you know this is your strain. Half into stress into strain. And what is your A into L part? This is nothing but volume, right? So this is actually your strain energy, or called your elastic energy for this rod or wire. Okay. Now sometimes we are very interested to find out about a particular thing called ED. What is ED? ED is nothing but energy density, which we represent by small u. We will represent this by capital U. Small u. Small u is nothing but your capital U upon V. Energy density is nothing but your energy stored per unit volume. So capital U upon V. So which will give us the formula. This volume part will just get cancelled, and you will get half into your stress and into strain. Okay, that's it. So this is your energy density formula. So इतना ही था हम लोगों का, और तो कुछ था नहीं. आई थिंक इतना तक आपको क्लियर हो चुका है. And you can try solving the questions from AC Verma, and if you want you can try solving Resnick Halliday from this part or DC Pandey from this part. Okay, now आज के लिए इतना ही रहने दो. ये चैप्टर आपका खत्म, जितना कराना था मैंने करा दिया आपको। द क्वेश्चन आंसर्स विल सॉल्व। ओके, इनफैक्ट हो सकता है कि मैं नेक्स्ट चैप्टर आपका स्टार्ट कर दूं और उसी के बीच में मैं आई टेक सम क्वेश्चंस and will solve in front of you so that you have a better understanding of the topic, or I can make a separate video lecture completely dedicated to question answer solving of this chapter. Okay, I will decide on that, don't worry. Clear? So this is the part. Okay, thank you और फिर मिलेंगे दोबारा।